For question 7, we're told that the line mx minus y minus 2 equals 0 intersects the circle with equation x squared plus 6x plus y squared minus 8y equals 4, and we are asked to find the two possible values of m. So we're going to solve these simultaneous equations. So I'm going to call the line equation 1 and the circle equation 2. I'm going to rearrange equation 1 to get it in the form y equals, and we've got mx minus 2, and then I'm going to sub that equation into my equation of the circle. So we get x squared plus 6x plus mx minus 2 all squared minus 8 lots of mx minus 2 is equal to 4. So we've got a quadratic here that we need to expand, so x squared plus 6x plus m squared x squared minus 4 lots of mx plus 4, subtract 8mx, and then we've got a negative 8 times by a negative 2, so we've got plus 16 equals 4. So we've got 1 plus m squared x squared. So I've just factorised my coefficients of x squared here. So we've got 1x squared, and then we've got an m squared x squared here. And then we're adding, we've got 6x, subtract 4mx, subtract 8mx. So that's going to become negative 12mx. So we've got 6, subtract 12m, lots of x. We've got plus 4, plus 16, so plus 20 equals 4. And then I'm going to rearrange that into a quadratic equal to 0. So I get 1 plus m squared x squared plus 6 minus 12m x plus 16 is equal to 0. Now the question says that the line with the equation touches the circle. So if it touches the circle, it means that it only has one solution. So that means we must have the discriminant is equal to 0 because we've only got one solution. So we want to use b squared minus 4ac is equal to 0 because the line doesn't intersect the circle, it just touches it. So b squared, that's 6 minus 12 all squared, subtract 4 lots of a, which is 1 plus m squared, times it by c, which is 16, and that is equal to 0. So we've got, oh, that should say 12m. When we expand that first bracket, we get, I'm just going to write it as 6 minus 12m times 6 minus 12m. Minus 4 times 16, that's minus 64 lots of 1 plus m squared, and that is equal to 0. So we've got 36 minus 6 times 12, that is 72, m minus 72, m plus 144 m squared, and we're subtracting 64 and subtracting 64m squared, that is equal to 0. So we get 144m squared subtract 64m squared, that is equal to 80m squared, minus 72m minus 72m, we've got minus 144m, and 36 subtract 64, we've got minus 32, that's equal to 0. We can divide Sorry, just made a very little mistake there. We should have minus 28 instead of minus 32. So that should say minus 28. We're then going to divide everything by 4 and we get 20 m squared subtract 36 m subtract 7 is equal to 0. We're now going to solve this quadratic. I'm going to use the quadratic formula to do this. So we get m is equal to 36 plus or minus the square root of negative 36 squared, subtract 4 times 20 times negative 7, all divided by 2 times 20, and we should get that's equal to 9 over 10 plus or minus root 29 over 5. And that is our solution for M. For question 8, we are first of all asked to find the vector AB in terms of Q. So AB, that is equal to vector B subtract A. So we've got 10i plus qj subtract 4i plus 7j. So 10i subtract 4i, that is 6i, and then we've got q subtract 7j. For part B, it says, given that AB, the modulus of AB, is equal to 2 root 13, find the two possible values of q. So the modulus of AB is equal to 2 root 13, so that means the square root of 6 squared plus q minus 7 squared is equal to 2 root 13. Now if we square both sides, we can then get that 6 squared plus q minus 7 all squared is equal to 2 root 13 all squared, which is equal to 4 times 13. Okay, so then we get 36 plus q squared minus 7q minus 7q plus 49 is equal to 52. So we get q squared minus 14q. We've got 36 add 49, 36 add 49, which is 85, then subtracting 52, so we should get plus 33 is equal to 0. And we can factorise this, so we've got q minus 11, q minus 3 equals 0. So q is equal to 11, or q is equal to 3.